Hello everyone, welcome back to Nated Engineering. We are doing Heat Engineering Science N3 and we have 4 parts in Engineering Science N3 Heat. We have the first one which will be dealing with heat transfer, the second one which deals with expansion, and the third one which is steam. So today we are going to start with the one that is dealing with heat transfer. So first, heat is represented by the letter Q and given by the formula M times specific heat capacity times change in temperature, and the SI unit is joule. So what is heat energy? Heat energy is a form, or rather heat is a form of energy that flows from one object to another. The flow is caused by temperature difference, and it is always from a high temperature object to a low temperature object. What this means is that if we are having two objects, this object is, let's say, 100 degrees Celsius, and the one next to it is 30 degrees Celsius. Say this is object number A, and then this is object number B. What's going to happen here is that there will be a flow of heat energy, number one, because of the temperature difference. And that flow will be from object A to object B. Why? Because heat always travels from a higher temperature object to a lower temperature object. That heat transfer will take place up until we have the temperature of object A being equals to the temperature of object B. At that point, there will be no heat transfer or heat flow because now there is no temperature difference. The temperatures are the same. The temperature of object A rather, will be equals to the temperature of object B. And if we are to avoid or if we are not to consider the losses, that the heat that is lost to the surroundings, we are going to say the heat energy which is lost by object A is equals to the heat gained by object B. And since we know that heat energy is equals to mass times specific heat capacity times temperature difference, we can then come here and say the mass of object A times specific heat capacity of object A times the change in temperature of object A is equals to the mass of object B times specific heat capacity of object B times the temperature difference of object B. This will be representing the heat lost, and this will be representing the heat that is gained. We then have something else, specific heat capacity. What is specific heat capacity? Specific heat capacity is the amount of heat needed to rise 1 kg of a substance by 1 degree Celsius. This tells us that objects are different and they require specific amount, unique amount of energy to make an increase of 1 degree Celsius. You might find that we are having object A and object B. Let's say object A needs 5 joules to make an increase of 1 degree Celsius, whereas object B requires 10 joules to make an increase or a change in temperature of 1 degree Celsius. That will tell us that this is the specific heat capacity of object A, and this is the specific heat capacity of object B. It's the same as you and a child. If you are hungry and the child is hungry, you will both eat, but you are not going to eat the same amount of food, whereas both of you will be full. If empty represents 0 degrees Celsius and full represent 1 degree Celsius, if you get from empty to full, we can say you have experienced an increase of 1 degree Celsius, but you and the child didn't eat the same amount of food. Let's say you ate 8 pieces of bread and the child ate 2 pieces of bread. The pieces of bread will be representing the amount of heat needed. And if empty is 0 degrees Celsius and full is 1 degree Celsius, both of you has experienced an increase of 1 degree Celsius, but you didn't require the same amount of bread in this case. So bread will be representing heat energy, and then the empty to full will be representing the temperature increase. This tells us that temperature is not heat, or it's not equals to heat. Temperature is temperature and heat is heat. So exactly what is temperature? We have 2 definitions that I'm going to share with you. Temperature is the measure of the average kinetic energy of the particles in an object. This one is a little bit deep for our syllabus. We are not required to know what is happening when an object is exposed to heat in the atomic level. So we are going to go with the second one, which says temperature is the measure of how hot or cold something is. It's that simple. And we are going to move to what we call the heat value of a fuel. Heat value of a fuel. So what is fuel? Let's start there. What is fuel? Fuel is a material or a substance that is burned to produce heat. An example, we have wood. We burn wood to produce heat, using it to maybe warm our house, warm ourselves, or to even cook. We have coal, we have petrol, we have many types of fuels. And just like each and every substance that we have out there, fuels are different in a sense that they produce a different amount of heat energy when they are burned. So we have what we call heat value. Heat value is sort of like specific heat capacity, but now the heat is given off because we are dealing with fuel. And the heat value will be the amount of heat energy that a fuel produces when 1 kg of that fuel is completely burned. So if we are having wood and we say that wood, let's say, produces 100 kilojoules of energy when we are burning 1 kg of it, then that heat value or calorific value, as you might as they sometimes call it. Sometimes you might find them saying calorific value or heat value. So the heat value of that fuel will be 100 kilojoules per kg, which tells us that if we were to burn completely this piece of wood, we are expected to receive 100 kilojoules of energy. If we are having 150 as the heat value of coal, this tells us that if we are going to burn completely this coal, we are expected to receive 150 kilojoules of energy. And that is what heat value really is. And it is given in kilojoules per kg. That is as the SI unit of the heat value for solid fuels. Solid fuels, it's wood, coal, and then we have gas fuel. The SI unit will then be kilojoules per meter cube. So the heat value of gas, or we can say liquid fuels, the heat value is given by kilojoules per cubic meter, and the heat value of wood fuel is given by kilojoules per kg. And that is everything that we need to start. It's everything that we need to continue this section of heat, which is the heat transfer. We are going to look at linear expansion and area expansion on the next video. And that is what I had for this video. And something I forgot to mention is that the SI unit for specific heat capacity is also joules per kg. It's kilojoules or joules per kg. That is for specific heat capacity. And that is the end of our video. I will see you on the next one.